Mathematics, Analysis and Approaches, Paper 1, Time Zone 1, HL, May 2025. This is question number 10, carries 18 marks. He is given as a quadratic equation. He wants us to write this in the vertex form, and later he also wants us to sketch the graph and solve the inequality less than 40. And then he defines another function g of x, which is ln x, and he wants us to write the composition of the function f of g of x, and then solve the inequality f of g of x less than 40, and ultimately find the domain of f of g of f of x. Now, converting this to the vertex form can be done in multiple ways. Ideally, -1 and -3 is going to be the point where the curve is going to be cutting the x-axis, the x coordinate, which is -1 and -3. So the vertex is going to be between them. So you can do that. And because a is positive, I know it is going to be an upward parabola. But we will use a different method. I believe that's a simpler method to find out or to convert this to the vertex form. Let me quickly do that. So what I have is f of x as equal to 5 times of x plus 1 into x plus 3. So I've successfully converted that to the vertex form. If I'm comparing this with the vertex form, I would have f of x as equal to x minus h the whole square plus k. So by comparison, I can say that the a value is a 5, and the h value is a -2, and then the k value is a -5. What I'm going to do now is to find out the point where this particular curve is going to be cutting the y-axis. For me to do that, I'm going to take this equation here, which is 5 into x squared plus 4x plus 3. So when I substitute the value for x is equal to 0, I will get the y value as 5 into 0 plus 3, which is basically 15. So now I know that the curve is going to be cutting the y-axis at the point 0, 15. I now need to find out the points where it's cutting the x-axis. For that, I'm going to substitute the value for y is equal to 0. And from here, I'll get the value for x plus 1 is equal to 0, or x plus 3 is equal to 0. That gives me the value for x is -1, or x is equal to -3. So using all of these, I'll quickly go ahead and plot the curve. That's the x-axis, and that's going to be the y-axis. So I can say that -3 is somewhere here, and then -1 is somewhere here. And I could choose the value for 15 over there and draw a approximate curve, something like that. And also mention the vertex being h, k, -2, -5. And that's going to be your graph. Right, let's look at the next part of the question. So let's solve the inequality f of x less than or equal to 40. So I'm going to go back and choose this equation. Plus 3 is less than or equal to 40. Transposing 5, I will have x squared plus 4x. So that's the solution for part C. Let's now look at part D. So we have f of g of x. So that's going to be your f of g of x. Let's see what he's asking for. And then he wants us to solve the inequality less than 40. Well, we have already solved this inequality, so we can probably make use of that. So here, for this particular inequality, the function was ranging from -5 to 1. So instead of x, I'll simply put a ln x there. So -5 less than or equal to ln x less than or equal to 1. And if I'm converting all of these to the exponential form, I can write this as e to the power of -5 less than or equal to x less than or equal to e to the power of 1. And therefore, in this case, x will simply belong to e to the power of -1, comma e. Now I'm supposed to be finding the domain for g of f of x. So for that, I first need to find out what is g of f of x. So that's going to be ln x, ln of f of x. And what I know is that the function ln is defined only for positive values, and that would simply mean that f of x has to be greater than 0. And that would tell me that 5 times of x plus 1 into x plus 3 has to be greater than 0. Again, going to the wavy curve method, I would have minus 3 here, and then a minus 1 here, and positive, negative, positive. This would simply mean that x is belonging to minus infinity to minus 3, union negative 1 to infinity. That is the solution for this particular equation or question. It's a pretty simple one, but yet a bit extensive. I've chosen very simple methods, though it seems a bit extensive, the solution itself, but the methods chosen are pretty simple, so that anyone who looks at this will be able to understand. That's it for this video. Thank you.